Now we have another problem. A little different, a little more complicated. But let's set up our table and let's see what kind of relationships and proportions and ratios or proportions actually, that we can determine how this works. And this has got some interesting things here. This whole thing is 15 and this is y and x. So we're going to be playing some algebra games. That's what we talked about. Algebra is simply the rules by which we do math, okay, and by which numbers are related with each other in this universe. So if we know the rules, then we can play the rules and we can do some magic with those rules and we can create things out of nothing if we need to. So let's look at this. Let's look at the small triangle. What is the short side of the small triangle? Well, the short side looks like it is, let's use our blue here, is y. Okay, what is the long side? Well, the long side is not identified, so we're just going to leave it blank. What is the hypotenuse? The hypotenuse of the small triangle is 5. Very important you get that down. Now, let's look at this median triangle here. The short side, again, it's not labeled, so we're going to leave it blank. And the long side, or the long leg, is x. And the hypotenuse is z. Wow, we've got 3 unknowns or more in there, and we only got 1 known. How's this going to work? Well, let's look at the large one. The short leg of the large one is 5. The long leg is z. And the hypotenuse is 15. Okay? This doesn't look like a whole lot of fun, does it? Let's rewrite this a little bit into a little bit different terms. It's x, but what's another way we can say x? The whole thing is 15. This piece is y, so we could say that x equals 15 minus y. So if we can find out what y is, we'd know what x is. And if we know what x is, we know this, and we can find out what z is. Woo! We got a plan. Let's go. Let's see what we can do. You ready? You help me out. Because what we're going to do is we're going to find out what y is by using this relationship right here. Okay? This relationship right there. Y is to 5 is 5 is to 15. Let's put it over there. Y is to 5 equals 5 is to 15. So 15y equals 25. Y equals 25 divided by 15. Oh, let's find us an answer for that one for sure. And that equals 1.6 never ending. Okay? Is that right? Yeah. 1.6 never ending. Huh? Is that 1.6 never ending? Yeah, I think so. So let's look at that. Okay? 1.6 never ending. So if that is 1.6 never ending, what is x? X is 15 minus y. If we were to do that, we'd look at this right here is 13.3 never ending. Okay? You ready? So if we know that is 13.3 and that's 15, then what do we got? 13.3 never ending over z equals z over 15. Well, that looks like z squared equals 13.3 never ending times 15. Oh goodness, what are we going to do with that thing? Well, we're going to try to solve it. 13.333333 times 15. Okay, that equals, so z squared equals 200. Z is going to equal the square root of 200, which equals 14.14. All right, so we have a z of 14.4, well, 14. Okay? Got it? So, what's our y? Our y equals 1.6, never ending. Our x equals 13.3, never ending. And our z equals 14.14. Okay? Let's see what we got. How we made that work. Yeah, okay? Now, see if you can find an error in that. If you do, well, let me know about it, okay? But that's how we would use that. All right, we've got one more we want to try. And hopefully by that time you'll get some, figure out how this works, all right? Okay, this is the last of our samples on how to work with this geometric mean thing and how to set up these tables for all of our similar triangles. Okay, so let's do this one. Let's set this one up and find our x, y, and z. Okay, let's take our small triangle. Our small triangle, the short leg is x. All right, the long leg is y. And, oh, well, that's wrong. Very wrong. Okay, make mistakes. Look at this, right? That is z, and our long leg, and our hypotenuse is 3. So let's look at the medium. That is z. This is y, and our hypotenuse is 3. Okay, let's look at our big one. Oh, this is easy. That's 3, 4, and that is 5. Well, this one's going to come out pretty easy. Why? Let's just look at this. We can find x simply by doing this right here, can't we? All right, so let's do it. X is to 3 as 3 is to 5. So 5x equals 9. X equals 9 divided by 5, or equals, I think, 1.8. So there we've got x. X equals 1.8. So now let's look and see if we can find y. Well, y looks pretty easy too, because y is just what? This little thing right here, isn't it? So let's go find y. Okay? Y is to 4 equals 4 is to 5. Y is to 4 as 4 is to 5. So 5y equals 16. Y equals 16 divided by 5. That equals 3.2. So our y equals 3.2. Now we've got the z to pick up, okay? What do we know about x? It's 1.8. Y is 3.2. So now can we find z? Most definitely, let's look at z, because z is where? It's this one right here. Okay? Alright, and what we've got is 1.8 is to z equals. Z is to 3.2. Well, take our z's. Z squared equals 1.8 times 3.2. Got an answer for that somewhere, I think. Alright. Oh, I didn't do that one, so let's do that. 1.8, 3.2 equals z squared equals 5.76. I don't want z squared, I want z. So z equals the square root of 5.76, which equals, I believe, 2.4. So what's our z equal? 2.4. Now, are there other ways you can do this? Yeah. This is a 3, 4, 5 triangle. That means every one of these triangles is a 3, 4, 5 triangle. Okay, so this hypotenuse here is to this hypotenuse as this is to this. this hypotenuse is to this hypotenuse as this is to this. Well, guess what? This shows us that. You got it? 5 is to 3 as what? Z is to 4. 5 is to 3 as X is to 3. You got it? 5 is to 4 as 4 is to Y. 5 is to 4 as 3 is to Z. Okay? 5 is to 3 as 4 is to Z. Alright? So those are the relationships. This table maps out these relationships and shows you the proportions that are set up. And most of the time these proportions end up being what? Geometric means between two numbers. Z is a geometric mean between 1.8 and 3.2. Y is just by itself. X and Y we were able to find by themselves. However, we could have used geometric mean to find those also. Okay? So those are the samples. Try some. Come to class. We're ready to talk about it and solve some. These are some of the things that are going to be on your regular test. More complex, more advanced will be word problems where you're going to have to draw a picture and then determine what these are. Again, these are methods of geometry, calculation of segments that would allow engineers, mechanical, civil engineers, construction workers, contractors, designers, architects to measure and calculate the measurements of construction pieces, beams, trusses, so forth and so on. And also would allow programmers, software programmers and systems programmers to design software, to embed that software into ICs, integrated circuits, into chips that would automatically calculate these things in calculators and construction calculators, in computer programs that people could just put the measurements in and it would come up and measure these things. Very specialized type programs. So the ability to use this opens up some windows and some occupations along those lines.